This is a video on integration using power series. The question states, use a power series to approximate the integral with an error less than 0.001. And we have the integral from 0 to 1/2 of the arctangent of x cubed over x dx. So the way I'm going to do this is to look at the arctangent of x and find a power series for that first. So note that the arctangent of x is equal to the integral of 1 over 1 plus x squared dx. And this is good because this could be realized as a geometric power series with u equals negative x squared. So what I get is the summation from n equals 0 to infinity. Well, negative x squared to the n, the negative pulled out as a negative 1 to the n, and x squared to the n becomes x to the 2n. So now this is an absolutely convergent series between negative 1 and 1, and in particular between 0 and 1/2. So that means I can take this integral and push it inside the summation sign and then integrate. Negative 1 to the n is just a constant, and the integral of x to the 2n is x to the 2n plus 1 divided by 2n plus 1. Now that's the arctangent of x. We want the arctangent of x cubed over x. So everywhere I see an x, which is this one spot, I put in x cubed. What I get is the integral from 0 to 1/2 of the arctangent of x cubed over x dx is equal to the integral from 0 to 1/2 of the summation from n equals 0 to infinity of negative 1 to the n. Here's my x cubed to the 2n plus 1 over 2n plus 1, and here's my x in the denominator, dx. So now let's simplify a little bit. The power rule says that x cubed to the 2n plus 1 I can multiply, and I get 3 times 2n plus 1, or 6n plus 3. And then x to the 6n plus 3 divided by x to the 1 is just x to the 6n plus 2. So I still have an absolutely convergent series between 0 and 1/2, which means I can integrate inside the summation sign. The negative 1 to the n over 2n plus 1 is just a constant, and the integral of x to the 6n plus 2 is x to the 6n plus 3 divided by 6n plus 3. And I'm still going from 0 to 1/2. So now let's plug in. If I plug in 0, all those terms are just 0, since I have x to a positive power. And if I plug in 1/2, what I get is the summation from n equals 0 to infinity of negative 1 to the n times 1/2 to the 6n plus 3 over 2n plus 1 times 6n plus 3. Now this is an alternating series because of the negative 1 to the n. So that tells us the remainder is going to be no more than the next term. So let's look at some terms. Let's first let n equals 0. Look at the 0th term. And I plugged that in my calculator, and I got a sub 0 was 0.042. And then if I look at the first term and take an absolute value and plug it in my calculator, then I got a sub 1 in absolute values is 0.00007. And the important thing is that a sub 1 is less than 0.001. So that means that if I take it as far as just a sub 0, just the 0th term, then that will approximate my integral at least as accurate as 0.001. So my final conclusion is that the integral from 0 to 1/2 of the arctangent of x cubed divided by x dx is approximately equal to 0.042. And my error is less than 0.001. And I'm done with the problem.